The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our next presentation, we have two speakers, both from Holcim, both technical services engineers. We have Todd Laker, who's going to present first, and followed by Brooke Smartz. I'll turn it over to you. Thank you.
Thank you. As you said, I'm Todd Laker, and I am located in Salt Lake City, Utah. Holcim has a plant in Devil's Slide, and Brooke will be on in a bit. She's from Colorado and will share some of the experience that we have with Portland-Limestone cements in Colorado. In our presentation, we hope to show where we have actual projects that use the Portland-Limestone cement that are in service and performing well today. When we look at Portland-Limestone cements, the bulk of our experience comes in the paving market. We have over 150 miles of concrete paving in Colorado and Utah, the bulk of which is in Colorado. These paving projects cover interstate highways, city streets, and rural roads. And we also have some experience with some commercial projects, which we'll get to in a moment. When we look at the opportunities that we've had with paving in Colorado and Utah, a lot of that is based off of the allowance of performance-based specifications by the Colorado and Utah DOT. They have accepted ASTM-C 1157 for over 10 years, and that's the avenue in which we've been able to promote and construct these projects with the Portland-Limestone cements. Additionally, the specifications in these states allow for additional supplementary cementitious materials to the Portland-Limestone cements, and this is to help mitigate potential ASR aggregates, as well as in locations where sulfate resistance is required. Holcim has been producing Portland-Limestone cements globally for many years, but in Colorado and Utah we've been producing the Portland-Limestone cements for over 7 years. And when we started to create the Portland-Limestone cements, we understood that it was important to verify the durability of these products before we put them out into service. So we used standardized ASTM testing to prove its durability. We looked at obviously fresh and hardened concrete properties to make sure that equivalent performance was achieved. We looked at how they would perform in sulfate resistance, alkali silica reactivity, freeze-thaw and de-ice for scaling resistance, shrinkage, and chloride ion penetration. And this table shows we ran two different concrete mixtures, a 500-pound cementitious concrete mixture with 0.5 water cement ratio, as well as a 564-pound cementitious with 0.45 water cement ratio. And we compared the predominant OPC, which was produced at the given plant, against the Portland-Limestone cement. So you can see a little vague on the chart, and we have more information available, but this would be the Portland-Limestone cement at a given plant, and you can see that through these different plants, and one of these I believe was with a Class F fly ash, we get equivalent performance. As Dr. Weiss talked about, that's really what the goal is, to find a Portland-Limestone cement that will perform equivalent to the OPC. And in all of the different categories and different tests, we found equivalent or better performance with the Portland-Limestone cement. Once we had these results and were comfortable that the product would perform well in the field, we initiated controlled field applications where we were able to test strength and set time and water demand, and found that all those were very equivalent to the C150 cements. We also learned that they were equally compatible with fly ashes and the different admixtures that our customers were using. Many of the contractors commented on improved finishability. So we were comfortable that we had a product that would perform equally with a lower environmental footprint. As we look at the different cement plants that are producing the products, the Devil's Slide plant, as shown here, produces a Type 5 clinker. So we have a C3A of less than 5%. And from that clinker, we produce two cements. The predominant OPC is a Type 2.5, meaning that it will meet the moderate and high sulfate resistance requirements under C150. It has about 4.5% limestone underground. This is in conjunction with the limestone addition that's allowed under C150, and it's a low alkali product. The other cement is our 1157 10% limestone cement. We've tested this under 1012 sulfate resistance, and it'll meet a GU and MS sulfate resistance. So for the next few minutes, I'd like to go through some of the different actual real-world applications where we've used the Portland-Limestone cement in Utah. The bulk of our experience comes from paving, and the first project that we did was actually a rural county road near Morgan, Utah. This is the main route to our cement plant, our Devil's Slide cement plant. So this comes off of the interstate into our cement plant. So we have major truck traffic, raw material trucks coming in, loaded cement bulkers going out. And as you can see, this is a very mountainous area, and we have some interesting construction restraints. This is a small creek here that goes into a confluence of a larger river, which crosses underneath a railroad crossing. A lot of different construction restraints which require that this be a hand-placed pavement. So this is 3,000 yards, hand-placed, ready-mix batched concrete, utilizing our 10% limestone and 20% Class F fly ash. It met all of the compressive and flexural strength requirements. The ready-mix customer who produced the concrete used their typical DOT mixture and just supplemented the cement. It's a DOT mixture that they have a lot of experience with, and the Portland limestone cement results were above those of their traditional results from this mix. This is a mountain climate, and we have some severe weather. So this was placed in the spring, and this was taken later that December with 2 feet of snow on it. So it's definitely gets the best of both worlds, and it's performing very well. After that, we were able to be a part of the pooled fund ternary study, which many of you are aware of. This was in conjunction with some of the work that Paul Fikowski was doing at the University of Utah. This project, 104th, is a fairly substantial city street in South Salt Lake. And what we were able to do is this was all constructed with an OPC, our 2.5 cement. And we were able to get 1 day's production with the 10% limestone and 25% Class F fly ash, which is this section right here. And as you can see, it looks beautiful, right? You can see the different strengths from the control section and the actual. The control section was slightly lower. We saw better strengths with the test section. Since this time, this last fall, this section was cored. The DOT went out and cored the section, both the test section and the control section. They broke the cores and found that the strengths were very similar over the years. And they looked at the amount of chloride and its depth of penetration and found that there was less penetration with the Portland limestone cement. So this is continually monitored through the pool fund study and performing well. Later that year, we were also we had a larger project, SR 201 in Salt Lake. This brings the west side of the valley into downtown. The eastbound lanes were paved in August of 2009 with our OPC Type 5 cement and 25% fly ash. And later that fall, they did the westbound lanes with the Portland-Limestone cement. You can see the differences in the compressive strengths, but when we look at the October placement, no cold weather applications or specifications were induced, no precautions were taken, no hot water, and so the difference in strength is explainable there. That project is performing well, and we hope to work with the DOT to core that sometime in the future to see how the strengths have worked over time. Another large infrastructure project which is recently completed was the Front Runner light rail transport connecting the north and south ends of the Wasatch Front to Salt Lake City. On this there was over 50 bridges, and many of those bridges used CMUs to build up the approaches. The block manufacturers in the Wasatch Front have utilized Portland-Limestone cement for over 6 years. So you can see one of the major walls was 37 feet tall, with 55 block courses above grade and 10 block courses below. And these walls utilize the 10% limestone. We do have some experience with the commercial market. This is the Meldrum building. It's the civil engineering building up at the University of Utah. This was Dr. Tukowski's office. After the success with the 104th South project, he specified the use of the limestone cement on his building. So this used a lot of SCC. You can see there's some inlaid, a lot of inlays, architectural inlays with engineering equations and portholes. It was placed in the winter. Did not see any setting time issues or anything like that, which is sometimes what we hear. There is an issue there. Going back to block, the architectural blocks have been produced with Portland limestone cements for many years. This school here at Ben Lomond used split-phased, honed architectural colors. The block manufacturers have noticed that the color of the cement is slightly lighter because of the limestone, and they've found that it is a more consistent color. And finally, we have a ready-mix facility. One of our customers produced this maintenance shed. You can tell that they are committed to sustainability. Not many people would submit their maintenance shed for LEED certification, but it is under review. And interestingly, this one, we worked with the customer and tried to get a ruling on innovation, a point in innovative design by using the Portland limestone cement in conjunction with fly ash to lower the amount of CO2. So that's pending. But now I'd like to turn the time over to Brooke for the Colorado experience.
Thank you, Todd. Good morning. Now I'm going to take you across the border into Colorado. Our Portland, Colorado cement plant is located about 2.5 hours south of Denver and is a fifth-generation facility. The first plant was built in 1897. Obviously, this is not an 1897 facility. This plant was rebuilt in 2002. It's a modern preheater, precalciner system. We also have solar power capabilities at this plant. We produce a Type 2 clinker, one which meets the optional low alkali requirements, and then a Type 2 clinker with an alkali level of about 0.75%. From that, we make several types of cement. Oops, didn't mean to do that. One of which is Type 2 low alkali, Type 2 cement. We make a 1P blended cement, which is primarily used in the Nebraska paving market. And then the focus of our presentation today is our ASTM C1157 Portland limestone cement. We've engineered this cement to perform similar to our ordinary Portland cement. It contains 10% limestone. It also, as Todd referred to, passes the performance test meeting the general use requirements, and then also the ASTM C1012 for moderate sulfate resistance. So with that, I'm going to highlight some of our transportation, commercial, and residential projects where Portland limestone cements have been used on a regular basis since 2007. Our first paving project, this is our first mile of our over 400 lane miles that we have in Colorado with Portland limestone cements, was with the City of Denver. And this is the 40th and Havana project, which is located in the Stapleton development. If any of you that have been to Denver remember the old Stapleton airport, it has been redeveloped into a very sustainable green community. Obviously, Portland limestone cement concrete makes a perfect choice. This was our first project. The contractor did 2 trial mixes, one with the type 2 cement and 20% Class C ash, and then a second trial batch with the Portland limestone cement and 20% Class C ash. With this project, since the Portland limestone cement was considered the new product, we did a side-by-side test. The eastbound lanes we did with type 2 cement concrete, and then the westbound lanes we did with the Portland limestone cement concrete. We didn't have any noticeable performance differences. In fact, we had a lot of positive comments on finishability. This did go into wintertime construction where we experienced some abnormally cooler temperatures for October. And as a precaution, the city engineer required that a portion of the concrete have a higher cement content in the Portland limestone concrete. We later learned that wasn't necessary, that we didn't need that. The strengths ended up being through the roof, and it was an unnecessary field adjustment, but a good experience nonetheless. Since then, we've done a lot more concrete paving with the City of Denver. We have the Central Park Boulevard project, which is considered the gateway from the east side of Denver into the City of Denver. And this is a very large $50 million project also in the Stapleton development. This particular contractor used Portland limestone cement and 20% Class F fly ash in all the concrete paving throughout this development area. They achieved excellent strength, and the project is performing very well. This project was completed in 2012. Also interesting to note, in this particular project, the contractor used an optimized aggregate mix design with the Portland limestone cement, and we've seen a lot of positive results with that. Next time you're traveling in and out of the Denver International Airport, portions of Pena Boulevard are being reconstructed. They've unfortunately prematurely experienced durability issues with problems with ASR due to the time when DIA was being built. Aggregate sources were being brought in from many different sources where they didn't have good experience with. And anyway, this is a very innovative project. The DIA engineer, Glenn Freeler, has taken the concrete, rubblized it, and used it as base for the future concrete, for the replacement concrete pavement. This will be receiving an ACI award. This is also a CDOT Class P pavement used with Portland limestone cement and 20% Class F fly ash and an optimized aggregate. They've exceeded all design strength, and DIA engineers are very happy with the project. Our first major highway project was U.S. Highway 287, near Lamar, Colorado. This is part of the Ports to Plains highway system. To my knowledge, this was the first major mainline paving project across the United States with a Portland limestone cement. This is a jointed concrete pavement with 540-pound cementitious Portland limestone cement and 20% Class F fly ash mix. This particular project was constructed during very hot summer months. started in July when temperatures were over 100 degrees. And this was really the turning point for us with Portland-Limestone cements in Colorado, because this was the first major highway project. The contractor had the backup mix design of a Type 2 cement with 20% Class F fly ash. And when we got out the gate with the first paving, we started to see low 7-day breaks with the Portland-Limestone cement concrete. And of course, being a major project, the initial reaction is to, oh, it must be the cement. We need to switch back to the Type 2. Well, luckily we were able to work through with the contractor and the CDOT engineers on what the root problem was, and it was actually a testing issue. The samples were being transported long distances to where the flexural beams were actually being made, and so the results that we were seeing were not representative of what the actual in-place concrete strengths were. So again, felt that was a turning point. The contractor kept using the Portland-Limestone cement mix through the entire project, and at the end they received their incentive award per CDOT specifications, and all flexural strengths exceeded design requirements. Since then, again, highlighting other projects, this is I-25, which is the major interstate highway. This is about 30 minutes south of Denver, near Castle Rock, Colorado. You can see beautiful Pikes Peak in the background. This was 5 miles of Portland cement concrete pavement done with Portland limestone cement and 20% Class F fly ash. This was a different contractor. All the contractors in Colorado have used Portland limestone cements. Again, this had an excellent flexural strength. This was 2 phases of this project in 2008 and the second phase in 2009. And again, this contractor also received their incentive award per CDOT specifications. Taking you into some highlights of commercial projects. About 2 hours south of Denver is Pueblo, Colorado. And this is the Pueblo County Health Department building. This is a 42,000 square foot building built in 2009, and this was the first LEED building, health department building in the state of Colorado. The local ready mix producer developed concrete mix designs with local and recycled materials and Portland limestone cements, including mixes that ranged from 15 to 25% Class F fly ash. In the footings, foundations, flat work, and also above grade walls. This was another project where all strengths exceeded design requirements, and the finishers also noted that they enjoyed the improved finishability. Sometimes in Colorado we can lack fines in the sand, and we often get unsolicited compliments from finishers, which sometimes are hard to come by with Portland limestone cements. This was certified as LEED Gold. Currently under construction in Pueblo is the Pueblo Judicial Center. You can see the bottom left construction photo, and the top right is the architectural rendition. This is the same ready mix concrete producer using Portland limestone cement mixes with 15 to 25% Class F fly ash. And this one has a lot of lightweight concrete and is performing very well as far as getting the 28-day mix designs, or 28-day strengths. And last but not least, I know they're offering AIA credit with this presentation, so if anyone is heading out to Denver for the AIA National Convention in June, we have the Legacy Project, which was part of the AIA Colorado Design Build Contest, is a home that's being built in Kittredge, Colorado. And all the concrete there is concrete that contains Portland limestone cement and Class F fly ash. Again, footing, foundation, flat work type construction. But just one example of the concrete that's being used on a regular basis in Colorado with Portland limestone cements. So with that, just to remind everyone, as members of ACI, I know we're all very passionate about this subject, that no quality cement or supplementary cementitious materials can offset low quality concrete. I think that's something that we as an industry need to continue to work on with everybody through all levels of construction of what can affect the quality of concrete. And when good practices are followed, as we all know, you can meet or exceed service life, which ultimately is the definition of sustainability. So with that, we hope that Todd and I have given you some examples of how Portland limestone cements are used on a regular basis since 2007. And I just would like to respectfully remind everyone that we have structures around the world that have not been built with ASTM C150 cement, and that there are other options out there. And I also invite you to come out to Colorado and Utah and see these projects firsthand. Thank you.